Welcome to Mind of a Scientist. It is my great pleasure to introduce Sophia Grubb and Dyanna Stetina, civil engineers at Brelgy and Race. Thank you so much for joining us today.
Hello, everyone. Diana and I are very excited to speak with you today. I'm Sophia Grubb, and I'm a civil engineer at Brelgy and Race Consulting Engineers. We're going to talk a little bit about our backgrounds and then our day-to-day life, and talk then about some projects that we've worked on in the last couple of years. I grew up in Rohnert Park and in a family of engineers. My father is an electrical engineer at Keysight Technologies. From a very young age, my parents had identified that I had this propensity for math and science, and so they began to expose me to STEM fields and encourage me that that might be a future career path for me. I participated in programs like Expanding Your Horizons and Introduce a Girl to Engineering, both programs that focus on encouraging young women to explore STEM fields, teach them a little bit about what it means to be an engineer, and give them an opportunity to do hands-on projects. And from those experiences, I learned that I loved the math and science, but what I loved even more than that was the ability to look at a project, look at an issue, and identify what needed to be fixed, and then using those math and science tools to solve the problem. It was kind of like a puzzle, which I love doing. In high school, I did a summer internship at SSU in a chemistry lab. And from that experience, I learned that pure science really wasn't for me. I liked the more practical, hands-on engineering side of science. And I decided that that was what I was going to pursue as a major in college. So when I was applying to colleges and selecting a major to study, I did some research, got the good Google out, and read a little bit about different types of engineering. And a little bit on a whim, I decided to apply to different colleges as a civil engineering major, with the idea that somewhere along the line, I may decide to change if a different type of engineering was a better fit for me. But in my first quarter at UC Davis, I took an introduction to civil engineering class, and I felt very impassioned by the water resources and environmental side of civil engineering. I liked that the environmental engineering was the interaction between humans and their infrastructure and the environment, and how we, through our engineering, protect the environment and also protect our infrastructure from the environment, depending on the situation. In college, I not only was there for the academic side of things, but I was really excited to get a well-rounded experience. So I joined many clubs, and in particular, I was in the UC Davis marching band, which through that, I met amazing people that I don't think I would have met otherwise, and made stronger connections with those that were in my major or similar majors. And those people really became my support system, my study buddies, the people that I did group projects with. And to this day, they're a very strong part of my network. We talk about our careers, and if someone needs a little bit of help finding a job or something, we're always there for each other. As I was graduating college, I decided I wanted to further my education and go and get a master's degree. I applied and I ended up going to UC Berkeley for a master's. And one thing I liked about that was it was a one-year program. And because it was a one-year program, I got to take a wide variety of classes in a short amount of time. I got to take everything from water economics and to a statistical analysis of groundwater contaminants, most of which I've used in my career now. When I was going through my education, I had made a connection with a woman, Edie, and she was a family friend, and she really took me under her wing. She became a mentor of mine. And one thing she did for me was introduce me to other women in engineering. And I did a number of job shadows with her, one of which was another woman, Sarah Yardley. Sarah had gone through the same master's program as I had. And so when I was graduating from grad school and looking for a job, I reached back out to Sarah, and she introduced me to her boss, who also had gone through the same grad school program as I had. And the rest is history. That's the job I ended up with. And I've been at Brelgy & Race for 6 years now, almost. And Sarah was there for only a short amount of time because she was at the end of her career, but I really soaked up as much as I could from her and learned as much. And I have other strong women now that I work with, Dyanna, that I also look up to as professionals. So Dyanna, would you like to speak a little bit about your background?
Yeah, thank you, Sophia. So I grew up in Colorado, and unlike Sophia, nobody in my family is an engineer. My parents were the first people in their family to graduate from high school and also from college. And they always encouraged us to explore, try lots of different things, explore interests, find out what it is that we like, both in terms of academics, but also, passions for causes or hobbies. And so I had an interest in math and science, and I had a science teacher that invited me to get involved with a program called Colorado River Watch. And we would go out into various creeks in our community and collect water samples and bring them back to our science lab to analyze them for different water quality parameters. And we would collect samples in different locations, either upstream or downstream of town. And it really opened my eyes to the impact that humans have on water quality, and really sparked an interest in environmental science. And as I learned more about environmental science, I also kind of started to environmental engineering. And like Sophia, I liked the practical side of things, the ability to solve problems rather than just understanding them. So I was pretty focused on engineering as a good career option for me. In high school, I became more involved with environmentalism and learning about climate change, and also started to consider, in addition to environmental engineering, potentially mechanical engineering as a way to address energy use and emissions more directly. And I applied to a whole bunch of schools. All I knew was that I wanted to get away from my comfort zone. And I ended up at Carnegie Mellon in Pittsburgh, Pennsylvania. Fortunately, at that school, you do not have to declare your major until the end of your first year. So I got to take a semester-long introductory course in 2 different types of engineering before I had to pick. So I took a course in mechanical engineering and a course in civil and environmental. And ultimately, I found that I liked the sort of big picture site or even citywide view that you get from civil engineering, rather than a more narrow focus on something like a single machine that you might have in mechanical engineering. Also, I just found that I felt more comfortable and got along with the people in my class, both the students and the professors in civil. And I kind of hoped that that would translate to my colleagues in the future, and I feel that it does. In my civil program, we didn't have to declare a specialty. We got just a general civil degree, and we got to try out different topics. And so from the climate change, I also thought transportation seemed like a good topic for me because of the ability to directly affect transportation systems and emissions. I took an introductory course in transportation engineering, and I interned with a city transportation department. And I found that I just didn't really like the work that much. I mean, I liked it in theory and the effect that it could have, but it was, it's very formulaic. You use a lot of like tables and guidelines rather than diving into like chemistry and science and biology the way that you get to do with water resources. So by the time I graduated, I was still feeling a little bit scattered because I had been focused on transportation and then found I didn't really like it. And it was also 2011, which was not the best time to be looking for a job during the recession. So I decided I did not want to pursue a master's. I didn't know yet what I wanted to focus on. So I just started looking for jobs, and a friend of a friend connected me with David Long, who's my current boss and mentor at Brelgian Race. And I had some really great phone conversations with him. It sounded like an awesome company to work for, and that they did a lot of interesting projects, that it covered a broad range of topics. Yeah, so through a little bit of persistence and convincing the company that I did in fact want to move to Santa Rosa, they offered me a job, and I've been there for, gosh, almost 10 years. And a few years ago, I was invited to join the ownership team. So I've also had the opportunity to learn about kind of the business side of things, which is a unique, to me, benefit of working in the private sector. So I think we want to do kind of just a quick overview of the type of work that we do at Brelgian Race. We focus mostly in water resources, but we also do some land development. We are, we'll pick up a project from the very beginning. So we'll get to do kind of planning and feasibility level work all the way through the nitty-gritty details of construction and inspection. And we do drinking water, wastewater, recycled water, and then for land development, we'll do paving and grading, stormwater, flood protection. Yeah, a really broad variety of things. And because it's a relatively small firm, we have the opportunity to work in many of these sectors. We're not forced to specialize too much unless I guess we really wanted to. Sophia, do you want to talk a little bit more about what we do and what our office is like?
Yeah. One other thing that I do as well, and I think Dyanna has done this as well too, is the regulatory side of things. So for every built infrastructure, especially with wastewater, there is a permit that goes along with it. So we do a lot of the preparing of the documents to get these facilities permitted and continue to operate within the regulations of the state. We work predominantly in the office, working with a number of different programs, Word, Excel, and also a computer-aided design AutoCAD program, as well as other like modeling programs, hydraulic pipes, modeling pipes, and how the water flows through the pipes. We work with a number of different people. We have drafters in our office that help us with drafting. They're much faster and more efficient at doing it than we are as engineers, although we do end up doing it sometimes as well. And we have an environmental specialist, Justin, in our office, who helps us with CEQA and making sure that we're staying within the environmental guidelines. And on a project, typically we have a project manager, and under the project manager, 1 or 2 engineers working on the project. So you get really an intimate experience with the project, and I get to work with clients, and when I'm doing construction management, I get to work with the contractors, and definitely getting to have a hand in every part of the project is something I really love about my job.
That's one of my favorites as well, is the getting to see a project all the way from start to finish, and all of the different personalities that you have to work with along the way, both in our office and then with the client, with the regulatory agencies. It's a little bit more of a communication effort than I think I anticipated when I got into engineering. We do a lot of writing, every time we design something or calculate something, we have to really communicate that to people who maybe don't have the same technical background, who I guess often don't have the same technical background. So that's an interesting piece of our job that I really didn't know I was gonna get to do. Sophia and I are not the majority in that we are women in our office. I think we've had anywhere between 2 to a peak of maybe 5 women out of, how many engineers do we have? 20 or 25?
Something like that, yeah.
But I've always felt very supportive. It's more just a result of the demographic from times past than necessarily an indication of the current culture or even the current, graduates coming out of engineering programs. I think it's a lot of people stay at our firm for a long time, so we don't always have job openings. So I think it reflects the demographics of 10 or 15 years ago rather than currently.
And a lot of our women engineers in our office are all on the younger side currently. And so I think that more accurately shows the demographics of what's going through the schooling system right now. I think, especially in environmental engineering, I found that in my grad school class, it was close to 50-50. But when you get into situations where there's a wider variety of ages skewing towards people who have been in the industry for a number of years, they tend to be more skewing towards the male side.
Yeah, and I think that the people we work with, I think when you're talking about the regulatory side or other engineering or architectural consultants that we work with, the demographics are largely the same. But as soon as you get into construction and contractors, that is even more strongly dominated by men. So I think that's where, if we're dealing with contractors, is where we have the most sort of not necessarily offensive situations, but just sometimes kind of comments that are more bizarre than anything. Not that it happens all the time, and it's not something to be like afraid of to enter the field, but it's just kind of a part of the job. Should we talk about some specific projects that we do?
Yeah, I think so.
Okay, I'm gonna put up the slides. Okay.
Excellent. You want to switch?
Oh yeah, next slide. How do I do that? There.
So the first project I'm going to speak about is the Alliance Redwoods Conference Gown Septic System Improvements. And I think the first thing that we should do is talk a little bit about what a septic system is, because some of you may or may not know. So a septic system consists of a tank underground, and wastewater flows into that tank by gravity. And that tank has a detention time, a time that waste then sits in that tank, and what we informally call bugs then treat the wastewater through an anaerobic process, and then flow out either by gravity or is pumped out into a leach field, which is just a system of underground pipes that have holes in them that allow the treated water to then soak into the ground and get further treated by the soil. So that's a little bit about a septic system. A little bit about Alliance Redwoods specifically. Alliance Redwoods, some of you may have attended a camp there or gone and done their zip lining. They are a camp in the Redwoods near Occidental, and they have some unique aspects. Campgrounds are really unique in that they have large influxes of people, and the people, when they're there, they're all showering at the same time. They're typically using the facilities all at a concentrated time. So you have these high peaks where a lot of flow is coming into their septic systems, and then nothing or very little once the campers leave. Do you want to, next slide? So Alliance Redwoods, before we got involved, had a very localized system. They had small septic systems that treated wastewater in their localized area from the camps that were, the cabins that were around those areas, and then they pump up to the next, and so on and so forth. So there's here 4 stages, what we called stages. They're just geographic areas. They pump from one to the other before that they got distributed into the fields. And one of the issues they were finding was that there was no good way to deal with these peak flows. When everyone was taking showers all at once, it would kind of wash out these septic tanks, and they wouldn't have the proper amount of time to actually properly treat the wastewater. And because it was mostly from showers and stuff, there were a lot of hair and other materials that would then clog up these pumps that weren't really the proper pumps to be handling water that wasn't fully treated. So they had issues with the pumps clogging and causing potential overflow incidences. Next slide. One of the reasons this is really an important thing is that Alliance Redwoods is right next to Dutchbill Creek. Dutchbill Creek is a really important salmon habitat, and the camp didn't want to negatively impact the stream and the ecosystem by having a sewage overflow. Also, operationally, these overflows were happening during storms in the middle of the night, and the crews would have to be out there in the dark, in the rain, and they wanted to reduce the amount of operations as well as their potential impact to the stream. Next slide. So instead of having these localized, what the solution we came up with was having a centralized treatment. So we installed grinder pumps, and grinder pumps are pumps you can see in the lower right-hand corner. They have a little blade at the bottom that takes everything that's in the wastewater and chops it up really finely so it doesn't clog up the pump or the pipes downstream. And we installed these pump stations at stage 1 and stage 2. And so they pumped all the raw sewage up to a new centralized treatment location. Next slide. So these are the new tanks we installed. We installed 3 new tanks, and the biggest one in the farther in the image is the septic tank. Now that was big enough to now treat all of the wastewater from the entire camp. And then the tank right before that is what we call an equalization tank. Now the equalization tank is empty most of the time, but when you get these really big high flows, it would slowly fill up. And then there was a pump in that tank that would slowly meter the water into the septic tank so that it wouldn't get overwhelmed and wash it out and reduce the amount of time the sewage was in the septic tank. So it would get fully treated. And then to be extra cautious, we even put filters which is what you can see in the left picture. And those filters would further reduce the chance that the pumps would get clogged. Next slide. These are what the final product looked like. The two top images are the pump stations, and then the bottom image are those tanks all covered up, and there's a field right there, a soccer field. And some unique things about this project was that we were able to construct the project with keeping the entire existing system completely functioning, which was really important to the camp so that they wouldn't have to not have guests for a period of time while the construction was going on. And the other thing is we were able to further reduce the chances of overflows because we kept those old septic tanks in the ground, we pumped them out, and they became emergency overflows. So if for some reason the power was to go out and the pumps couldn't pump, the water would flow into those old septic tanks and there wouldn't be an overflow incident. So that is this project. Dyanna?
Okay, a lot of the work that I do is for the wine industry, and I like doing winery development projects because often they're industrial sites, they have a lot of unique needs, and they're often in rural settings, places where you don't have public water and sewer serving the property. So we are responsible as the civil engineer for pretty much everything outside of the buildings themselves. So that would be paving, grading, stormwater, drinking water, wastewater systems. And those are not things that it's simply just getting the wastewater to the street and then it's off to the city. It's treating everything on site. And I love that it's kind of an opportunity to practice in so many different types of civil engineering. It's too much to talk about everything, but I'm going to focus on the drinking water and the process wastewater system as just an example of some of the unique challenges that we have with wineries. This is an example from a project we recently completed where they had an existing well on site. This is a photo of the well house before construction that they were already using, but it didn't have any kind of treatment system on it. You can see the dust on the floor in the well house has a red color to it. That is because there's really high iron concentrations in the well water. And iron doesn't have any health concerns, but it has aesthetic concerns. It has taste and odor to it. It can stain plumbing fixtures and glassware. So obviously for winemaking, something that's about taste and flavor, iron was something that we had to treat. Typically you treat iron using chlorine to precipitate the iron, so you get it to go from liquid to solid so that you can catch it with a filter. Chlorine is also something they don't really like in the water they use for winemaking because it can affect fermentation and flavor. So they asked us not to use chlorine in this case. So we had to come up with a creative solution that used a water softener instead to get the iron to precipitate. And typically we also use chlorine for disinfection to make sure that there's no viruses or bacteria in the water once it reaches the tap. And in this case, we used UV disinfection instead, which is just as good at disinfecting, but it doesn't have the same long-lasting effect that chlorine does. So we had to treat the water on demand. So it gets stored in a tank, and then as it's used, it passes through this UV system, which is basically just that these stainless steel tubes that say Viqua on them are just a big UV light, and the water passes under the light to be disinfected. Wastewater from wineries is a tricky thing to deal with because it's what we call high strength. It has a lot of like sugars in it from the winemaking process. So it's the bugs that Sophia described, there's a lot of food for the bugs. So, and in a septic system, the bugs don't usually consume oxygen. They're what we call anaerobic or anoxic. And in winery waste, often we'll want to use aerobic microorganisms. So they consume oxygen. So these tanks in this photo are bioreactor tanks. They're fed in air from some blowers to keep the oxygen level high enough to support all these bugs. And there are compartments, little containers in the tanks that have some media that support a broad diversity of different kinds of microorganisms to eat all of that food. And they have to get circulated around and around to make sure that all of the food is eaten up. And then as a polishing step, which was unique on this project, this is something I've never designed before, it passed through a peat filter. So peat is a partially decomposed organic material, which is relatively affordable. So it's kind of a nice solution for this winery. And the peat has chemical, physical, and biological properties that make it a really good polishing step for wastewater, and also reduce nitrogen, which is difficult to treat, and especially in smaller systems. From here, it goes to a leach field, which is the same technology that Sophia described for Alliance Redwoods with the septic system. I think that was all I have. Oh, sorry. This is the system when it's finished. So the big silver box above the ground is a screen. It catches large solids like grape skins and stems before it goes into treatment. The little green lids on the ground are the tops of the tanks that were shown in the first picture. And then the black tank that's above the ground is that peat filter. And the lift station is out of the photo off to the right. That's it for our presentation. Does anybody have any questions?
So Stefan asks, what would happen if there were no microorganisms to clean the wine wastewater?
That's a good question. I think that regardless of whether you provide the microorganism, it's sort of like they come anyway. There might be some very small amount that ends up, gets picked up on the floor in the winery or something, and whatever can survive by eating the food that is available in the wastewater becomes a more dominant species within the microorganism mix. So it's something that just is generally naturally occurring. Once you've got it up and running and you keep feeding it food in the form of wastewater, the population will sustain itself.
Also, if you have issues with that, aren't there some systems that can dose to do us in the startup? Occasionally, if that's an issue, they will dose the system with those microorganisms.
Yeah, so if your population is not big enough to treat the wastewater, it basically will be untreated. You'll have, there's a number of quality parameters that we check to make sure that the wastewater is being treated before it gets disposed. And basically those quality indicators would be too high, and it would be untreated waste without the microorganisms.
Have wineries always treated their wastewater?
No, and domestic wastewater also hasn't always been treated. The Clean Water Act did not happen until the 70s. So wastewater treatment and disposal was really not regulated. And I obviously haven't been an engineer for that long, so I don't know the history of when wineries were regulated, but it was definitely much simpler treatment would have been required before. You might have been able to just put it into a leach field without treatment, or maybe just a simple septic system. And with the number of wineries that there was at the time, the cumulative impact was not that significant on groundwater.
Sophia asks, I know this probably wouldn't happen here, but what would you do to prevent the water from freezing?
There, you are correct. That is not something that usually we have to worry about here in Sonoma County, which is where we predominantly do our work. But there are ways to insulate pipes and special types of tanks to prevent freezing of the water. Do you have
There's
anything?
also mixing systems. So if you keep the water moving, like if you've ever noticed, if you've been somewhere that's freezing and the stream is still not frozen, if you keep the water moving, it prevents it from freezing as well.
Riken asks, what is done with the impurities like the iron that is extracted from the well water? How is it disposed of?
That's a great question. That is the most overlooked thing in what we do. So that the iron or whatever it is that you're filtering out will get caught in the filters. That's the purpose of the filter. And then you have to do what we call a backwash, where you pass water backwards through the filter to lift up, to clean off all of those solids that got trapped. And that water gets captured somewhere else. And then you can either dispose of that in like a subsurface disposal system or send it to the sewer, if that's an option for you. Or you can, what we often do is we put it in a holding tank and allow all those solids to settle out, and then you recycle that backwash water so that you're minimizing your water waste.
When you design something, how do you test it before implementing it?
With well, with water systems, when you install water systems, there's certain things that you have to implement when you're, quote, starting up a system. So when you're putting it into service, and one of those things is you have to pressurize the pipes to make sure there aren't any leaks. And so they have to hold a certain amount of pressure for a certain amount of time. With like the Alliance Redwoods project, we started at the pumps, we made sure they all ran, we would operate all the pumps in all the different configurations. Things like the septic systems, you don't necessarily need to check to make sure they're working, because it's common knowledge, as long as the water is being held in those tanks for a certain amount of time, it's going to be treated. But mostly the mechanics of a system are all exercised or used during operation to make sure it all works.
How much of Sonoma is lacking in proper water purification equipment?
I don't know the answer to that question. I know that there are some communities that, for example, were designed with they each have their own septic system for each house maybe, and the density of that community has gotten to the point where the septic systems are kind of polluting each other, and if there's wells in between, then it's harder, it's impacting the groundwater. I couldn't tell you how much of the county is lacking. In terms of drinking water, I think that number is probably very small. I don't know, Sophia, do you have any insight on that one?
I am not sure. I don't know off the top of my head.
How expensive are these water purification systems?
It really depends on what you're treating, what you're treating. One of the things that I think our office kind of specializes in is smaller systems, which are relatively expensive for the quantity of the water that you're treating. And it's a tricky thing to design because there's not a lot of options in terms of like stock systems or methods of design. It really depends. There's certain things like iron and manganese are not that difficult or expensive to treat relatively, but certain constituents, like if you've got silica or something, it can get more expensive.
Also, one thing that our firm does is we have been involved in helping these small communities get grants. There's a lot of government money out there that is looking to help support small communities get safe drinking water. And so sometimes we can get grants to set up these filter systems and treatment plants for them. And there's also a lot of environmental groups like Fish and Game that are interested in funding wastewater projects for small communities. So sometimes we can get grants to help offset costs.
Do you have any tips for students who might be interested in pursuing a career in engineering?
Um, I would say make sure that you continue to explore all of your interests. I think that there's a misconception that engineering is all about math and science and just putting your head down and solving problems. And I found that I rely on my understanding of policy and my communication skills almost as much as my technical skills. Not that you shouldn't focus on technical skills, push yourself and challenge yourself and learn as much as you can. But I think keeping a broad level focus, especially while you're in middle or high school, is advantageous.
Yes. And I think I touched a little bit about this in my background, but I think creating a good network, going to office hours and meeting your professors and, you know, talking to them about what types of research they're doing and what opportunities might be there for you to work in their labs, and so you can get some hands-on experiences and do summer internships where you can, like Dyanna found, transportation was not for her, so she explored something different. And I think that, yeah, keeping your options open, looking at different soft skills, but making a network, because Dyanna and I both got our job by knowing someone that works at Brel Jean Race, and I think that's not unique to Brel Jean Race.
Mm-hmm. Can you tell us how you use AutoCAD for pipes, designing pipes?
There are a couple of different ways. Well, one is the simplest, to draw each design project. We come up with a set of plans so that the contractor knows how big the pipe needs to be, what size it needs to be. So we'll draw drawings to scale. The other kind of really interesting way that AutoCAD can be used is pipe networks. So Civil 3D allows you to 3D model the pipes and can help you figure out the hydraulics as well. You can calculate the hydraulics of a system and make sure, you want, if something's flowing downhill, the upstream is actually higher than the downstream in a network.
I was wondering if you could tell us what's the hardest part of your job and what do you find to be the most fun?
Oh. That's a hard question. I think the hardest part of the job is that, in a way, what we do is like basically just solve really complicated word problems, but we're only given like a third of the word problem, and we have to figure out the rest of the problem ourselves. We have to ask enough questions until we kind of fully form even just the question before we can start working on the answer. And sometimes that can be a challenging thing, especially when you're working with a client who's maybe not doesn't have the same technical background as you. So you have to explain even what it is that you're asking for to really get to the right answer. And the thing that's the most fun, I'd say, is constantly working on something new and different and getting to jump from topic to topic and getting to ask different people in our office and outside of our office with different expertise all the time, constantly having to learn just to be able to do our job.
I would agree with what Dyanna said, but for the sake of variety, I will say the hardest thing I find about the job is the writing. Writing was something I always struggled with in school, and like Dyanna said earlier, it's something we do every day. We write memos and technical reports and distilling this information in the simplest way possible, but still making the client understand what it is that we're doing and why we're doing it. I find very difficult, but practice makes perfect. So as I move forward in my career, I'm sure that's something that will become easier. And I think one of the best parts of my job are the people. In COVID times, that's been a little bit harder because you don't get I'm walking to to get a cup of coffee, and I get to stop in my coworker's office and just say hi and find out what they're working on. But typically I love my coworkers and everyone I get to work with every day, and that's a great pleasure.
Okay, well, that wraps up the recorded segment of this program.